Long before anyone carried a computer in their pocket, a quiet English mathematician named Alan Turing sat down to ask a question that sounded almost like a joke. Can a machine think? It was 1950. The world was still rebuilding from a war, and the few computers that existed filled entire rooms and were dumber than a modern pocket calculator. And yet that question refused to go away. To really understand the artificial intelligence you use today, the one that writes your emails and answers your questions in seconds, you have to understand the 70-year journey that began with Turing. Because the model in your browser is the latest answer to his question. Quick note before we dig in. If you find this useful, subscribe and drop a topic you want explained in the comments. Now, let us get into it. 6 years after Turing, in the summer of 1956, a small group of scientists gathered at Dartmouth College in New Hampshire. They shared a bold belief that human intelligence could be described so precisely that a machine could be built to imitate it. One of them, a mathematician named John McCarthy, gave the dream a name that stuck. He called it artificial intelligence. They thought they might crack it in a single summer. They were off by about 70 years. The first great era of AI ran on one confident idea. If you want a machine to be intelligent, you write down the rules of intelligence by hand. Experts would sit beside programmers and translate their knowledge into thousands of if-then rules. A medical program in the 1970s could ask a doctor a series of questions and suggest a diagnosis. A chess engine could follow the hard logic of the board. For a while, it felt like the dream was close. But these systems were brittle. They knew only exactly what they had been told, and the real world is far too vast and messy to capture rule by rule. Twice, once in the 1970s and again in the late 1980s, the optimism collapsed. Funding vanished. Faith dried up. Those cold stretches even earned a name. The AI winters. The thaw came from turning the whole idea upside down. Instead of writing the rules by hand, what if you let the machine discover the rules for itself, simply by showing it enough examples? This is machine learning, and through the 1990s and 2000s it quietly took over the world. You used it every day without ever noticing. The spam filter that learned what junk mail looks like. The bank system that flags a suspicious charge. The store that guesses the next thing you might buy. This was the age of predictive analytics. Feed a model a mountain of past data, and it learns to predict the next number or the next label. Will this customer cancel? Is this transaction fraud? Is this photo a cat? It was genuinely powerful, and it was everywhere. But it had a hard ceiling. Each model was a narrow specialist. It did one job, on one kind of neatly organized data, and it had to be rebuilt from scratch for the next job. Around 2012, machine learning got a dramatic upgrade called deep learning. Using layered networks loosely inspired by the brain, powered by the raw muscle of graphics chips, machines suddenly became remarkably good at seeing images and understanding speech. But even then, the old pattern held. You still built a separate model for every separate task. Intelligence was still narrow, still locked in its lane. The real turning point came in 2017, in a research paper out of Google with a cheeky title. Attention is all you need. It introduced a new design called the Transformer. We will spend whole episodes on how it works, so do not worry about the machinery yet. What matters is what it unlocked. For the first time, you could train a single model on an enormous amount of raw human text, the open internet, books, and code, and have it learn language itself rather than one narrow task. Then researchers did something audacious. They made it bigger and bigger. By 2020, a model called GPT-3 revealed something almost nobody expected. At a large enough scale, it could perform tasks it had never been specifically trained for, just from being asked. And in November of 2022, one of these models was wrapped in a simple chat box and handed to the public. It was called ChatGPT, and within 2 months it reached 100 million people. 70 years after Turing asked his question, a machine could finally hold a real conversation. So what actually changed? Why is a large language model different in kind from the predictive machine learning that came before it? For decades, applied AI was a collection of narrow specialists. One model predicted who would cancel. Another caught fraud. Another sorted photographs. Each was trained for a single task on carefully labeled data, and each was useless outside its lane. A large language model shattered that mold in 3 ways. First, it is general. One single model can summarize a contract, write code, translate a language, and explain a recipe without being rebuilt for any of them. Second, it speaks our language. The interface is plain words, not spreadsheets, so almost anyone can use it. And third, and most important of all, it is context-aware. This is the heart of the whole thing, so let me make it concrete. A large language model is still, at its core, a next word predictor. The same engine the field has been chasing since the beginning. You give it text, it predicts the most likely next piece, adds it, and repeats. But here is what changed. It is trained on so much language, across hundreds of billions of internal settings called parameters, that those parameters end up encoding the patterns of language itself. The grammar, the facts, the relationships between ideas. And the transformer gives the model the ability to weigh everything you have said so far before it chooses the next word. That is what context-aware means in practice. Give it the sentence after living in Tokyo for 10 years she was completely fluent in, and it leans hard toward Japanese. Change one word, Tokyo, to Madrid, and the whole prediction swings to Spanish. No human wrote that rule. The model is reading the context and adjusting on the fly. And that ability unlocked something genuinely new called in-context learning. You can show the model a brand new task with just a couple of examples right inside your message, and it will follow along with no retraining at all. The old narrow models could never dream of that. They had to be rebuilt for every new job. This one you can teach in the moment using nothing but words in the prompt. That is a new dimension, large language models added to artificial intelligence. Not a machine that mastered one task, but a single flexible engine you steer with context. There is one final piece that turns this raw engine into the helpful assistant you actually use. A model trained only to predict internet text is not naturally helpful. Ask it a question, and it might just reply with more questions, because that is what it saw online. So the labs add a second stage. They show it many examples of good, helpful answers, and then they let people compare its responses and reward the better ones. That human feedback is what shapes a raw predictor into something polite, useful, and willing to actually follow your instructions. This is also why the very same technology shows up so differently depending on who you are. As an individual, you open an app like ChatGPT or Claude, or you run a smaller open model on your own laptop with a free tool called Allama. As a startup, you rent a model through its programming interface and build a feature on top of it in an afternoon, paying by the word. And as a large enterprise, a bank or a hospital, you run an open model like Llama inside your own walls, grounded on your private documents, where control and privacy matter most. One breakthrough, quietly serving a curious student and a global bank with the same core idea. So the next time someone asks you what a large language model really is, here is the honest answer. It is the latest chapter in a 70-year quest that began with Turing's simple question. It is a next word predictor, grown to an enormous scale, made context-aware by its training, and shaped by human feedback into an assistant. Not a mind and not magic, but a genuinely new kind of tool, and arguably the most flexible one we have ever built. Over the rest of this series, we are going to take the entire machine apart, one piece at a time. How it breaks your words into tokens. How it turns those tokens into meaning. How attention lets it focus. And how you control its creativity. In the next episode, we begin exactly where the model itself begins, with tokenization, and you will see why the way it reads your words decides both what you pay and how well it understands you. That is the core of it. If this helped, hit like and subscribe, ring the bell for the next deep dive, and tell me in the comments what you want broken down next. Thanks for watching.